Okay, Rich, let's continue. Before we go to the nomenclature, shall we say, that your book uses, let me remind you of one thing that I know you're very familiar with. Recall that when you're writing the equation of a straight line, we had a standard form that we used, right? For example, you want to write the equation of a line in a standard form. You wrote it as y equals m times x plus b, right? You recall that? Well, I don't know. I guess some books use different constants, you know. It could be bx plus c. It doesn't matter. But you should recognize this, that you have a y on the left-hand side. You had your x, and then you had two things. The m, which is a constant, which represents the slope of the straight line, and you had plus b, which is the y-intercept. Okay, you must remember this. And this helped you a lot, remember? Because now, no matter how they gave you the equation of a line, if somebody wrote phi equals 3x plus y, it didn't matter. You could rearrange this into this form, and you'll be able to tell them that the slope is so and the y-intercept is so. Okay? Good. The same kind of thing is what your book does in dealing with the parabolas. They have adopted a standard form. This one that I wrote this way, I wrote as y equals ax squared. They write as x squared equals 4pp times y. It doesn't matter. To make your life easy, let's stick with the way the book writes it. But remember, what I told you here doesn't change. The shapes, it still depends. When you see this yx squared here, that tells you right away that for this one, y will never be negative unless this 4p constant is negative. So that tells you that, that will tell you that this is, and for both negative and positive values of x, both negative and positive values of x, y will be the same as long as it's, that is, remember what I just told you? So in this case, if x is minus 3, or it's 3, the y will still be the same, right? Because when you square x squared, minus 3 becomes 9, y becomes 9, so both of them will still be the same. And what does that tell you? That tells you that that parabola is something like that or something like that, depending on the value of 4p. If 4p is negative, is positive, then this parabola will be facing up. If it is negative, the value of 4p is negative, then this parabola will be facing down. Okay, you should be able to recognize that right away when you see something like that. Okay, basically the one, if it is x squared if it is x that is squared, then the axis of symmetry will be the y-axis. If it is x that is squared, the axis of symmetry will be the y-axis, or the axis of symmetry will be the one that doesn't have the square. To make this clearer, let's do this other side. Instead of x squared equals 4py, we now have y squared equals 4px. Look at what has happened. Now it's the y that is raised to the power of 2. It doesn't matter. It's still a parabola, okay? Okay, but you should pay attention to see which one is which. This case though, what is it telling you? It tells you that if you're changing, okay, let's use one that still got some ink in it. this is telling you that if y equals, let's say, -1, and then the case where y equals 1, okay, what is x? Y squared equals 4px. So if we know that y is -1, so -1 squared is 1, so that is x is 1 over 4p. And the same will be true when y is equal to +1. X is equal to 1 over 4p. So that tells you something, that when you are looking for where to plot the x, okay, it's going to be like that. It's going to, you see, it's going to be like that, right? Like that, or like that. We don't know yet, depending on whether 4p is negative or positive. If 4p is positive, then all x's must be positive, so it's going to plot like that. If 4p is negative, then all x values will be negative, so it's going to plot like that. Okay, I hope you understand that. That's just a standard way of writing it. So whether it's going to be the x that is squared or it's the y that is squared, don't worry about it. It doesn't matter. It just tells you whether it's upward facing or side facing. Well, it tells you whether it's upward or downward facing under this category, and under this category it's telling you whether it's leftward facing or leftward facing. That's all it tells you. So immediately you see which one is squared, whether it's x that is squared or y that is squared, you should be able to know, okay, I'm either dealing with up facing or down facing. Immediately you see that it's y that's squared, you know that I'm dealing with either left facing or right facing. And then what we now determine out of those two under each category is the value of 4p. Okay? That should be pretty clear now. Now, what is this p? It's pretty, like I said, it's like you had the slope as a constant, the y-intercept as a constant in the case of a straight line. It's a constant that for a given parabola helps us to determine the location of a special line called the directrix. The directrix is a special line associated with a parabola. I'm going to show you that in the next clip, okay? But that is the reason that p is introduced into all this. Just like the slope is very important when we're dealing with a straight line. The y-intercept is very important when we're dealing with a straight line. Well, the directrix is important when we're dealing with a parabola, and p helps us to determine where it is located. Okay, it's a property. So every parabola has a directrix, and p helps us. The value of p for that particular parabola will help us. Knowing it will help us to know where to locate the directrix. Okay, I hope that's clear.